So we'll start off by considering a couple of exponentials. Let's think about a to the power of x, and let's call that m, and say that a to the power of y is n. Well, if that's the case, then let's just rewrite then these in logarithmic notation. Well, this would be log am equals x, and this one on the right here, log an is going to be equal to y. So with that understood, let's see if we can put this into an expression and come up with something useful. So let's start by thinking about m multiplied by n. Well, that is going to be a to the power of x multiplied by a to the power of y. Which of course means we can add those powers together, so that mn is going to be a to the x plus y. And of course, we could just take logarithms of both sides, or what I mean by that is write this as a logarithmic expression. So what is it I have to raise a by to get mn? And of course, the answer here is x plus y. But if we go back to the top, we've got expressions for x and y in terms of logarithms. So let's use them. Our final kind of answer here is log base a of mn is going to be, well, x is log base a of m plus, and y then is log base a of n. And this, we'll call it our first law of logarithms. We can do more, right? Now that rule came from the fact we were using this mn. So it kind of makes sense then for us now to consider m divided by n. So let's get rid of this, and we'll see if we can find another rule that's useful, starting with m divided by n. So if I do that, well, I can write this in terms of my a's. This is going to be a to the x divided by a to the y. So of course, I can write this as a to the x minus y. And if I can do that, well, again, I can take logs of both sides. Just write this as a logarithmic expression. What is it that I raise a by to get m over n? Well, I raise it to the power of x minus y. And again, we've got the statement at the top there for x and y. So we could say log base a m over n is equal to log base a m minus log base a n. That is our second rule of logarithms, and we'll look at how we can apply these in just a moment. We've got one more though that we can find that's quite useful, and then we'll go and look about how we can apply these. So this time then, we won't look at multiplication or division. Let's look at raising by another power. So we'll start with m, but this time let's just think about, well, what would happen if I raised it to the power of something? Let's call it p. Well, that would be a to the x to the power of p, of course. We'll make that swap. And then, therefore, we can multiply those powers together, right? Power of a power, we do the multiplication. That's going to be a to the xp or px. And again, just like before, well, we can take logs of both sides. What is it that I raise m by? What is it I raise a by, I should say, to get m to the power of p? Well, that is going to be xp, or I guess we could write it as px. And just like in the previous methods, we can swap out the x. What is it I raise a by to get m to the power of p? It's going to be p, and then remember we had x is equal to log base a of m. This is our third and final rule of logarithms.